to talk about population dynamics, and that means population changes. Dynamic means changing. And sure enough, populations do change. They are dynamic. As we get further down the row, we'll start to talk about what's called dynamic equilibrium. This is a concept we do in chemistry. We do phase change equilibrium and equilibrium dynamics. Thing I want you to think about, if you like the whoa, deep parts of science, is this very instant, as we are sitting here talking, people are being born. There are new lives starting right now. Lots of them, all over the world. Lots of new, humans, rabbits, coyotes, wolves. That's the next one. Oh, that's the chapter, yeah.
So is this what this is, or no?
So this very minute, organisms are coming into the world and starting new life. And this very instant, organisms are winking out of their lives. People are dying and being born every second. Coyotes and rabbits and maple trees are also being born and dying. And blue whales. Somewhere right now there is a blue whale being born. Well, actually, seasonally, I'm not sure. Our birth rate and death rate. Not right now. Get caught up, and at the end I'll go back. So the big changing factors in any population that we tend to look at are birth rate and death rate. And the birth rate's easy. It's how many of that species in a population are born in a certain period of time. For humans, we tend to think about births per year. That doesn't make sense for some species. Fruit flies live for about 2 weeks. The number of births and deaths per year is ridiculous. So for them, we might say, births per day or deaths per day. But for a lot of species that have longer life expectancies, we tend to think in terms of years, births per year. And the death rate is just the opposite. The mortality rate is how many deaths you see in that population over that same period of time. Again, for humans and things like dogs, sea turtles, things that have long life expectancies, we tend to use per year. For other kinds of populations like insects, things that don't live a whole year, we might think in months or days or weeks. And then you have life expectancy. And that is simply how long, on average, an individual can be expected to live, the average lifespan. So I want you to discuss something at your islands. What I want you to discuss is this. In the Middle Ages, so think about the Middle Ages, the Black Death, castles, peasants, serfs, all sorts of pestilence and war. Yay! Were there any 80-year-old humans? Don't answer me out loud. Talk amongst yourself. Were there any 80-year-old humans during the Middle Ages? Middle Ages. 1400, 1500, 1300, 1000 Common Era. Castles and huts and terrible agriculture and pestilence and disease and warfare, lice. Everybody has lice. Or fleas, or both. Yay! The origin of lapdogs. Did you know that? You know why lapdogs were originally bred? To be a more attractive target for the fleas. Royalty would keep lapdogs because the dogs were thought to draw the fleas away from the people. Ugh. Yuck. Okay. I saw lots of people going, nope. Absolutely not. So who here says, yes, there were 80-year-olds? Who here says, no way? Okay. Who says, I don't know? Okay. It's actually a very sensible position to start from. So how many of you have heard this? You know, in the Middle Ages, the average life expectancy was like 30. Have you heard that? Okay. Maybe you've heard something along those lines. I think you do ancient civilizations in middle school someplace. Oh yeah, average life expectancy was like 30. So let me ask you this. If I have two people, I'll just carbon copy this person, and one of them dies at 1 year old, and one of them dies at 100 years old. What's my average life expectancy? What's the average age of death? How do you get an average? Add them and divide by 2. So my average life expectancy is 50.5 years. Oh. Let me tell you something about the Middle Ages. And it's funny, I just was reading something. I'm reading a book set in, it's during the reign of Suleiman the Great and the Ottoman Empire, 1500s in Persia and Italy. It's fascinating stuff. And this woman is basically part of the harem to Suleiman the Great and ends up marrying his son and, raising children who were royalty. And one of her children is very, very sick. And an older woman says to her, after this child recovers from, whatever the disease is. In the Middle Ages, anyway, in this book, her child, her baby, is like a year old and has some horrible illness. And, she's kind of beside herself. And after the child recovers, this old woman says to her, well, maybe this one will stick around. A lot of people said, well, you shouldn't get attached to your children until they're at least 5. I'm not kidding. Now, I always have to tread carefully with this one. I hope all of you are growing up with all the siblings who were born into your family. The odds are statistically good that that is the case. Both of my parents grew up with all the siblings who were born into their families. None of their siblings died as children. In the case of my grandparents, that's not so true. And in the case of my great-grandparents, there's at least one family I know of where 17 children were born in 22 years. Holy cow. 17 children in 22 years, or 25, something like that. 11 of them survived to adulthood. That was pretty common. My grandpa was actually named for a pair of dead twins. Ugh. As a kid, I found that morbidly fascinating. His father had baby twin brothers, and one of the twins died at 6 months, and the other one died at about 1.5 years. That was pretty common. People literally said, don't get attached to your children until they're at least 5. Because babies died all the time. Small children died all the time. They died of measles, mumps, diphtheria, pertussis. They died of fevers. They died of diarrhea. I mean, babies can die of diarrhea because they get dehydrated and they have a really hard time holding on to liquid. They're not all that tough. And so, if you have 100 people and 50% of them die before they're 1 year of age, and the rest of them live to be 70, 60, 80 years old, guess what your life expectancies are? Low. So that average life expectancy doesn't mean you can't get older than that. So yes, they had 30-year life expectancies in the Middle Ages, but a lot of that was due to what we call high child mortality. Today, we don't have that kind of rate of high child mortality in the industrialized world, so most children make it through childhood. There are exceptions. There are tragic exceptions. But usually, most babies make it these days. Not all, but most. So let me ask you this. When I ask you on a test, and I will ask you this on a test, if a population has a 75-year life expectancy, could there be a 100-year-old individual in that population? Yes. Average life expectancy for males in this country today, I think, is like 76. Average life expectancy for females is something like 78. Females are a little bit biologically hardier than males. Guys, I'm sorry to tell you that, but at every stage of the game, you die in greater numbers than females. It's true. From conception on, more males are conceived, and slightly more males are born, and the numbers for males decline the whole way. Females are just a little bit biologically tougher, made of tougher stuff. Females tend to live longer than males on average. How many of you have an elderly, widowed female relative? Grandmas, great-grandmas, aunts, yep. That's the pattern. Men tend to die first. Men tend to die a little bit younger than women at every stage of the game. But, so, okay, so males, let's say 75, women, let's say 77. Does anybody here know a woman who is more than 77 years old? Yeah. Anybody know a man who's more than 75 years old? Okay. You can live longer than your life expectancy. You can live longer than your life expectancy. Okay, which takes us to talking about this idea, which is survivorship curves. Now, you don't have any blanks on here, but that's the kind of thing that I'll probably put on as a bonus question on a test. So I want to talk about it a little bit. We're not going to stress it. This shows basically how likely you are to die at any given point in your life. Whoa. So we can think about this as the percentage of the population that's still alive. I should really get another color there. That's basically, and I know it goes up to 1,000 because it's actually a logarithmic scale, but we're not going to talk about that. That's the percentage of the population that's still alive, in essence. And at the very top, this is 100% of the population. Everybody that's born. And there's 0. And then this is percentage of maximum life expectancy. So average life expectancy might be 75 for females, but average life expectancy would be the oldest human ever known to have lived, which I think was like 118 years, something like that. And she like smoked and drank wine every day and had affairs with artists in France at the turn of the century. She was a wild woman. I saw an interview with her at one point. Holy cow. Not only did she have a long life, she had a lot of life. She was crazy. Old French lady. And I think she gave the whole interview with a cigarette in her mouth. Crazy genes. So, maximum lifespan. How long an organism could possibly live. The oldest member of that species ever to have lived. And these curves that you see here, so if we look at this, what this is saying is that for humans, most of us make it through the early years. And again, that's in an industrialized nation. That's in Europe, Canada, the U.S., someplace where you have reasonable medical care. We don't have lots of dead babies. This is 50% of life expectancy. So if the absolute maximum life expectancy for humans is 100 and, we'll just say 110 because I can do the math in my head, then 50% of that life expectancy would be about 60 years. So at 60 years, we start to see that people start dropping off. And until we get all the way up to that maximum life expectancy, they just keep dropping off. My great-aunt Gracie lived to be 98 years old. At 90 years old, she started waking up and having the following conversation out loud every morning. She was devoutly Catholic. Dear God, I would like to die today. I'm done. Everybody else is gone. I'd like to go now. Can I go today? She lived 8 more years. But you know what? She had buried 2 husbands. All of her siblings were gone. Everybody she had been friends with, raised her kids with, worked with, her old neighbors, she was the last person who had shared those experiences. There was nobody else who remembered the things she did. She was a sweetheart. She was a very sweet woman. And when you get out to this end of the survivorship curve, when you get out here, eventually there's one left standing. That's that 118-year-old French lady, the last one. So in this kind of survivorship curve, if you make it, you make it out to here, and then the odds start getting better and better every day that you'll die. I don't even know what the mathematical odds were for my Aunt Gracie every day after 90, but they were pretty high. Now, on the other hand, you have curves like this one. What does that curve say? Talk about it at your table. So here's 100% of the population that's born. Here's 50% of life expectancy. What does that curve say? This is the kind of thing that's a good bonus question on a test. You're making the squinty-eyed thinking look. That's good. Squinty-eyed thinking looks are good. Do a lot of this organism live to half of maximum life expectancy? No. A lot of them die early. Remember those hundreds of spider babies floating through the air that Josh wants to kill? Of 100 of those, that's what I think. Spiders are awesome. Of those 100 spider babies floating through the air, maybe 10 of them will live to see tomorrow. Because birds are going to eat them, and other things are going to eat them, and they're going to get smushed against car windshields, and, you know, against Josh's hand. Many of them don't make it. If they make it, then they can live a good life.
Until they get killed.
Well, until they get killed later. And then you've got species that have about equal chances of dying every single day. All right, so we're not going to talk about the type 1, type 2, type 3, because the one thing I want to talk with you about before we rat attack tomorrow is this, because this is an important concept to go into rat attack. Growth rate. And growth rate is the amount by which a population changes size in a given period. And again, with humans, we usually think annually. We usually think per year. With species that don't live that long, we might think by week or by day. No, we're going to talk about that. We're going to cut back to that one. And how that population changes really depends on the growth rate, the birth rate, and immigration-emigration. We assume that migration cancels out. So generally we say that growth rate equals birth rate plus death rate. And here's the question I have for you. If this is 100, if we have 100 births and 50 deaths, what's our growth rate? Positive 50. It's positive growth rate. Our population is increasing. What if we have 50 births and 100 deaths?
Negative.
Negative. We end up with a negative growth rate. We have a shrinking population. And we'll look more at populations that have positive and negative growth rates in the next couple of days. Okay. Tomorrow, you can head out if you would like. I would take your stuff. Tomorrow we are going to start talking rat attack. If you are not going to be here, it will be linked on Classroom. I loaded it into a PlayPosit. I haven't put the viewing guide questions in the PlayPosit yet, but sorry, Harry. I said sorry. So yeah, tomorrow we start with horrific footage of rats. It's awesome. I know. I'm so sorry you watched that whole thing. Remember, wait, the one other thing I wanted to say. If you turned in your species distribution pattern stuff and you put anything like source of information, what I learned in my project research, go back and find somebody else to say it. Mrs. Gabbard. How many of you have met Mrs. Gabbard? Okay. Mrs. Gabbard used to always say to her English classes, do you have a PhD behind your name? No. Then nobody cares what you think. Which is a little harsh, but find a source to say it. If you are pretty darn sure you know it for a fact, find a source to back you up. So if you think that your distribution of this species is random or clumped or even, find a source to back you up. For instance, nesting sites would drive dispersion patterns. All right. Have a good day, folks. Happy travels. Have a good day, folks. Happy trails to you. Oh my gosh. Yes.